All right, so our function looks like something like this: x to the power of n, x to the power of some exponent. As x approaches infinity, meaning as your numbers get bigger and bigger and bigger. So if x is, let's say, 1,000, and you raise it to this exponent, so 1,000 to the power of 5, 1,000 to the power of 8, 1,000 to the power of 10, the number is going to get even bigger. Now suppose x got even bigger than that, not 1,000, but suppose x was 1,000,000. Now if you have 1,000,000 to the power of something, it's going to get even bigger. So if you have infinity to the power of something, you're still going to get infinity, a much bigger infinity, but infinity nonetheless. Yes?
What if n is equal to 0? What's another constant?
Well, we're talking about any positive integer. Okay? So as I'm looking at x approaches infinity, and if I raise that to the power of something, then it's just going to multiply to an even bigger value of infinity. Now, what if I'm approaching negative infinity? In the case that your numbers are now at negative infinity, so when you're talking about negative 1,000, negative 1,000,000, it makes a difference as to whether the exponent is even or odd. So if you have negative 1,000 to the power of 4, an even exponent, or if you have negative 1,000 to the power of 7, an odd exponent, that's going to make a difference, okay? Because in this case, you're going to get a very large number, but it'll be a positive large number. In this case, you're still going to get a large number, but it'll be a negative large number. So if you have infinity, negative infinity, and your exponent is even, then you're going to get positive infinity as a value. If you have negative infinity and your exponent is odd, then you're going to get negative infinity as a value.
We should have learned this like 7 chapters ago. I learned so much.
So here's a visual representation. If n is odd, okay, so if the exponent is odd, 3, 5, 7, as your numbers get bigger into the millions and the trillions, it goes up to positive infinity. As your numbers get, further and further to the left, negative 1,000, negative 1,000,000, the values go down to negative infinity.
So for that,
okay?
would it be the limit of positive and negative infinity?
We'll see. We're going to do lots of examples here. Now, at infinity, suppose you have a function that looks like this. Suppose you have a function that looks like this. F of x is equal to x to the power of 4 minus x squared plus 7. Okay? Now, when you're in the realm of the infinities, so when you're at x equals 1,000,000, first of all, 1,000,000 to the power of 4, that's a huge number. Okay? So suppose you had $1,000,000, and now somebody said, you know what, I'm going to raise that million to the power of 4. Now 1,000,000 has how many zeros? 6. To the power of 4, that has 24 zeros. Okay? So if you have that much money, and somebody gives you $7, it's not even going to make a difference, right?
You can't buy luxury.
Okay. So compared to the million to the power of 4, this is negligible. Compared to the million to the power of 4, even this is negligible. So what I'm trying to get at is, as you go further and further into the infinities, okay, the terms with the higher exponent become more and more powerful. They become so powerful that they can completely knock out everybody else. Okay? So at the infinities, whether it's positive infinity or negative infinity, the only terms that matter are the ones with the highest exponents. Everything else is what we call negligible, meaning it's barely there. It doesn't make a difference. Okay? Yes.
So all you care about is the x to the 4.
Right, at the infinities. Now if I'm looking at, x approaches 5, there is no way I can get rid of these. But when I'm looking at x equals infinity, then none of these make a difference. Only the term with the highest exponent makes a difference. So even if it's like x to the power of 100 and x to the power of 99, the 99 still would be able to be thrown away. Okay, so let us...
Click on it.
Yeah.
Here we want to evaluate this limit as x approaches infinity. So at infinity, these terms are going to be negligible. The only thing that I care about is the term with the highest exponent. So this is going to be the limit as x approaches infinity of negative x cubed. The negative must come along because it'll make all the difference. Now, infinity cubed is still infinity, just a little bit bigger. But the fact that there is a negative in front means it's negative infinity. Here, this is going to equal to the limit as x equals negative infinity of 4x to the 6. Now, I have negative infinity, and if it's raised to an even exponent to the power of 6, then it'll be positive. So this is going to be positive infinity. What about this one? What is this equal to?
Negative infinity.
The limit as x approaches to negative infinity of what?
Negative.
See, it stopped again.
4x.
Of limit as x approaches to negative infinity of what?
4x.
4x to the 5. And now negative infinity raised to the power of 5 will be negative infinity. So negative to the power of 5 will still be negative. So that's the answer, negative infinity. Which means as x approaches negative infinity, this function, as x approaches negative infinity, this function is moving down towards negative infinity. Okay? That's what that means. Now, let's talk about reciprocal functions. See, is this recording now? Okay. All right, let's talk about reciprocal functions. Reciprocal functions are when f of x is equal to 1 over x. So let's explore this for a minute. Suppose you have x and you have 1 over x. Okay, now, when x is 1, what's 1 over x?
1.
1 over 1 is 1. Now, suppose x is 5. What's 1 over 5? 0.2. Now, suppose x is equal to 20. What's 1 over 20?
1 over 20. 0.02.
0.05.
Sorry.
Okay? So, what's happening here? Suppose you have a pizza and you're going to share it with just yourself. You have the whole pizza to yourself. Now, if 5 people come over, you're sharing it with 5 people, each of you are going to get 0.2. If 20 people come over, your share is going to get even smaller. Now, what if, now, you did 1 over 1,000? It's going to be 0.001, right? So as the number here in the bottom gets bigger, what happens to your value? It gets smaller. So as you divide by a larger number, your share gets smaller and smaller and smaller.
That's actually
Wouldn't it be bigger if it's 1 over 1,000?
Yeah.
Yeah.
Okay.
If x is because it's 1 over 1,000, so then it would flip around.
Right. So it would be 0. It would be. So what's 1 over 1,000? 0.
No, but if it was 1 over.
Oh, sorry. I meant to write that over there.
Oh.
Swag. No, I got what you were trying to say because I wrote 1,000 and then I wrote 1 over 1,000.
Right. I meant to write that over here. 1 over 1,000. So as the number that you're dividing by gets bigger and bigger and bigger, your share will get smaller and smaller and smaller. So if you are sharing that same pizza now with 1,000,000 people, each one of you is going to get like
piece of cheese.
A little tiny speck of cheese, maybe, okay? So now if you have an infinite number of people at your house, you're not going to get anything. Nobody's going to get anything. So as you divide by infinity, the value approaches what number? Zero. Okay? That's exactly what we're looking at here. As x approaches infinity, your graph approaches zero from here. And as x approaches negative infinity, your graph approaches zero from there. So whether you divide 1 over a million or 1 over a negative million, you're still going to end up with 0. Okay? All right. So let's see.
So do you always just put 0 for these?
No. Let's see what's happening here. We're still at infinity. And at infinity, the highest exponent still takes effect. That's always the case. So at infinity now, this is going to equal the limit as x approaches negative infinity. What I'm going to do is I'm going to take the term with the highest exponent from the top and the term with the highest exponent from the bottom.
Why is x have a higher exponent than 10?
Because x has an exponent of 1. This is x to the power of 1. This is x to the power of 0. We're talking about the exponent of the variable. So if you have x minus 10, that's the same as x to the 1 minus 10x to the 0. So here we have 5 over x. Now, x is now going to be infinity. Or actually it's going to be negative infinity, but it doesn't matter. Now, so think to yourself, 5 divided by infinity. It's going to be what?
Really small.
0. Okay? So, in your mind, you think 5 divided by infinity. However, you are never allowed to actually write 5 divided by infinity. You just do that mentally.
Okay. You think of infinity?
And
Infinity is infinite.
What? No.
Okay. So 5 over infinity, it's going to be 0. So that's the limit of this is 0. So as x approaches infinity, this approaches 0.
I'm confused on where the minus 10 went.
We ignored it because we're only taking the highest exponent. Now in this case, this is the limit as x approaches infinity of the highest degree and the highest degree here. So the terms with the highest degree rather. So it's negative 3x squared over 5x. And now we're going to do some simplifying. This is the limit as x approaches infinity. The x will cancel with that x, so it's negative 3 over 5 times x.
So it approaches infinity.
Now x is on top. Okay? That means you're multiplying by x. And when x is infinity, that means you're multiplying by infinity. So it's going to be a large number. Therefore, this is going to be negative infinity. The negative sign here makes that a negative infinity.
And then divide by 5 doesn't mean anything.
This is 3/5 of infinity.
Why don't we keep the x on top? Wouldn't that make a difference?
We're going to take the highest terms again. So this is going to be the limit as x approaches infinity of 7x cubed over 2x cubed. The x cubes cancel completely. So this is the limit as x approaches infinity of 7 over 2. I'm sorry.
Yeah, 7 over 2.
Right, which is just 7 over 2.
So is the answer just 7 over 2?
Right,
Okay.
the answer is 7 over 2. Now, when we were talking about sequences, we said that they could either converge or diverge. And what we had to do was we were picking points, and we could decide whether they converged or diverged. Now, we can write the sequence as a function. In that case, we can find the limit. If the limit exists, then we say the sequence converges. If the limit does not exist, then we say the sequence diverges. So here, we're going to have to write the first 5 terms of the sequence.
Starting from 0. I forgot where it is.